Hey Algebra, here are your 12-7 notes for the application of quadratic functions. So we're just going to be talking about our parabolas in terms of real-world scenarios. So what I gave you is a graphic organizer over here that'll really help you with your work. So if you ever have any questions about, well, what does the vertex usually mean? What is the y? What do my x-intercepts usually mean? This is a really good resource for you to use. But let's go ahead and dive in. So we're going to use our graphing calculator and answer the following questions. We have a suggested window, which is just telling us, hey, you're going to use these points so that you can see your graph. And if necessary, we need to round our answers to the nearest tenth, and we're going to include units in our final answer. So let's talk about launching an object from a platform. And so I have my calculator all ready to go online. So if we notice, I've just looked up a generic calculator online. Here is a TI-84. Okay, so we're going to go ahead and get started. We are launching an object off of a platform. This equation right here, negative 4.9 t squared, this equation tells us what happens, and we can physically see it. This window is saying, hey, I want you to change it so that you can see the graph from 0 to 7, and where the y-axis is only from negative 20 to 90, because we're probably not going to be able to see this graph after we plug it in. We're going to be able to ask ourselves, how high is the platform? At what time does the object reach its maximum height? What is the maximum height? And how many seconds does the object hit the ground? So before we can start anything, we need to know what our x and our y values represent. So when we're talking about launching an object, it's saying that the height, h, and t seconds. So notice how they wrote h of t. This is exactly like our equations where we write f of x or g of x. So we know that that h is going to be our y value. So we're going to say that y is our height, and our x value is seconds when we're talking about the x-axis and the y-axis. So important information to be pulling out of your problem, because if you don't know what your x and y axis represent, you're not going to be able to answer any of the questions. So let's go ahead and graph. So when you're using your TI-84, we are going to plug in our equation by clicking y equals, and then you're going to click negative 4.9 x squared plus 19.6 x, and we're using x because we don't have a t, so that's okay if we're using x, plus 58.8. Now, when we click graph, notice that we can't see our graph, so this is where that window comes into play. Okay, so we do actually have a window button on this calculator, so we can go ahead and click right here where it says window, and we're going to set our window. So we want to only see from 0 to 7 on the x-axis, so the minimum is going to be 0. We're going to click down and change it so that we can see the maximum of 7. We're going to skip the next line and go straight to the y minimum, and we want negative 20. And our y maximum, I'm stealing that from here, is 90. So now when we click graph, notice that I can only see what the problem is really wanting me to look at when it comes in terms of this. Okay, so when we're talking about how high is the platform, if we are launching from a platform, this is our starting point. So A is all about our y-intercept. So we want to find out how high is the platform. We need to find the y-intercept. So this is where we're going to start calculating things on our graph. So we want to see where it says calc. We want that blue button, so we're going to click second calc. And we want a specific value. And we know that when we're talking about the y-intercept, so letter A is talking about the y-intercept. We know that when we're talking about this, our x value has to be 0. So we already know a specific value that we want. So we're going to go ahead and use that value, or number 1, and click enter. And notice that it's only giving us an x value. So really, we can only use that first option to find our y-intercept. But we know for a y-intercept, the x value has to be 0. So we're going to plug in 0, enter. And right there, x, y, it gives us our y-intercept. So how high is the platform off the ground? It is 58.8. And we're talking height, so this is meters. Okay? Now, when we are looking at what time does the object reach its maximum height, well, there's our key word. For this one, we are looking for the maximum point. So going over to our graph, we need to find the maximum. So we're going to calculate again. So we want to click second, calc. And luckily for us, it says maximum right there at 4. So you can either jump down to the number 4 or click the number 4 and hit enter. Now this is where we have to be tricky. Notice that it says left bound question mark. So they're just saying, hey, where's the left side of the maximum point? And we're going to drag that cursor until we're about to the left of it and click enter. And then it changes to say right bound. So now we're going to change this so that it's to the right of our point. And so we got to be careful because mine's a little jumpy sometimes. So now I'm at a pretty good point where I'm on the right side of my maximum point, so I can click enter. And now they want us to take a guess. So where do we think that the maximum point is? Because it needs just a little bit more information. Oh, so I'm going to go back to my graph. Oh, I have to do it again. That's so fun for me. So you can kind of fast forward through this point, you guys, because I keep making a mistake. So you can skip through it. We've already done the left bound, so I'm just doing this again, going to the right side of my graph. I'm on the right side. Now I'm going to take my guess, and I think that my guess is right about here is my maximum. So if you notice, my maximum is 2.0 and 7.84. Now you might have gotten like a 1.99999, same thing when we're rounding, but you definitely should still see these two numbers really close. So the question is what time? So when we're looking at what time, we know that x is seconds. So we're looking for our x value, which is right here. So this is 2 seconds. And then if we're looking for the height, we know that the maximum height is the y. We're already got our maximum point. That is 78.4 meters. All right, last question. After how many seconds does the object hit the ground? We're looking for seconds. So we want to know if we hit the ground, we know that if this is our height has to be 0. So we're looking for our x-intercept. So let's write that down. We're looking for our x-intercept, one of our zeros. All right, so let's go ahead and figure out how we're going to find that. So again, we're going to calculate a new point. Don't forget that the x-intercept is also called your 0. So when we come over here, we're looking for the word 0. So we're going to either click 2 or jump down to the number 2, enter. Now, again, we want the left bound of our x value. So we want to go to the left side of the x value we're trying to find. So really clicking that button to get to the left side. So here's the left side. Now we know to go to the right side. So now I'm a little bit on the right side. And now we're going to take a guess. So I think that my x-intercept is right about there. So if we notice 6, 0, that is our x-intercept. So after how many seconds? It took 6 seconds to hit the ground. Okay? So now what we're going to do is move on to our next question. We want to know about the volume of water in liters. Remaining in a bathtub depends on the number of minutes that has elapsed since you pulled the plug. Okay, so we have a tub with water in it. We're pulling the plug. We want to know how much water was in the tub before we pulled the plug or when we pulled it. So there was water already in it. And how long does it take to drain the tub completely? Okay, so we're going to plug this in. Let's plug in our equation. So we're going to go back to y equals. We're going to clear our graph. We want 2.4x squared. We're going to subtract 24x and add 55. Now we can click graph. Now, if you notice, we can still see it, but we need to see it just a little bit better. So what we're going to do is change our window. So going back to window. We want our minimum to be 0, but we want to go to only 4 because we saw too much. We want our y minimum to be a -5, and the highest is to go to 60. So just making our graph a little smaller. So notice how that brought us in a little closer. Because we only have 2 questions, we only need 2 pieces of information. So how much water was in the tub when we pulled the plug? So if we haven't pulled the plug yet, there's already still water in it. So this is our y-intercept. So we're going to go ahead and click second calc. We want our value when x is 0. So clicking enter, and here we can see that our y value is y equals 55. So we have 55, and we're talking liters of water in our tub. Now we want to know, how long did it take us to drain the tub? So if we are looking for the tub to be completely empty, if this y-axis is liters, we're looking for when our liters is 0. So we're talking about a 0. So we want to second calculate. We want a 0. And now we're going to have to take our cursor and move it all the way over till we're on the left side of our x-axis. We're going to get just a little bit closer till we're on the left side of our point. So I'm on the left side of my point. I can click enter. Now I want to get to the right side of my point. So putting this just on the right side of our x-intercept. So right about there. And now they want me to take a guess. So I'm going to go back, and here is my guess. I think it's right about there. So if we take a look, we need to round to the nearest tenth. So our time is about 3.6 seconds. That's how long it took for our tub to empty. All right, jumping over, we're talking about Buzz Lightyear going out on a Saturday driving his spaceship. As he approaches Mars, he changes his mind and decides that he does not wish to visit that planet and fires his retro rocket. The spaceship slows down, and if all goes well, it stops for an instant before pulling away. While the rocket motor is firing, Buzz's distance in kilometers d from the surface of Mars depends on the number of minutes since he started firing his rocket. So before we do anything, we're going to look at our equation. We have d of t. So knowing that the d is distance, we have our y-axis equaling distance. And of course, our x-axis is in minutes. So important information, otherwise we can't read our graph. And I know I previously missed that on the last question, but just make sure you know what your x and y axis stand for. So now we're going to plug in our equation. We have a new window, and then we can answer 2 questions. So the hardest part is putting this in the calculator. 3x squared minus 78x plus 500. Now looking at our graph, I don't see it at all, so we have to change the window. We want our minimum to be 0, our maximum for our x to be 20, our minimum for our y to be negative 50, and we need to go all the way up to 500 on the y max to see our graph. So clicking enter, or graph, so we can see our graph. So notice that we can really see that graph there. So we want to know, how high above Mars was Buzz when he fired his retro rocket? So again, how high before he even did anything? We're at the y-intercept, so we need to calculate, second calc, our value at our y-intercept when x is 0, and we are at 500. So before anything started happening, he was 500, and we're kilometers above the ground, so 500 kilometers. Okay? Now, let's take a look at our second question. Does Buzz crash into Mars, just touch the surface, or does he pull away before touching the surface? And how do you know? So here's where we can use our information on what we know. So he's flying. Mars is at 0. So we're starting at 500. We're flying to Mars, flying to Mars, flying to Mars. And then all of a sudden, we're at 0 and we hit the ground. But notice how your parabola goes a little bit below that. So did we just touch the surface and jump away? No, it looks like we crashed a little bit. We crashed. So we can go ahead and write that he crashes. And we know that because the graph goes below 0 on the x-axis. Which is technically the ground. So he hits Mars, goes a little bit below it, and right there, he's probably not flying up. But if he was able to, the graph shows us what he would do. But he crashes because we go below the x-axis. That's how we know. All right, last question. Jack Potts dives off the high diving board. His distance in meters from the surface of the water, h, depends on the number of seconds, t, since he left the board. The equation ht equals negative 5t squared plus 9t plus 20. We have a new window. We have 3 questions. So let's first determine what our x and y axis represents. So the y, because it's h of t, the y is the distance, and we're in meters, and then the x is seconds. Okay, so again, knowing what our x and our y represents. All right, let's plug in our final graph. So we're going to y equals, we're clearing. We have negative 5x squared plus 9x plus 20. We want a graph. Notice we can barely see our graph, so we need to change our window. We want to go from 0 to 4, and we want to go from negative 10 to 30. We're going to click graph. Now we can see a beautiful arch. We want to know how high is the diving board. So notice he's diving off of it. He hasn't gone anywhere. He starts. So that is our y-intercept. So we're going to go ahead and click second calculate. We want our value where x is 0. So notice that we are at 0, 20. So we are at 20 meters. That's how high our diving board was off the ground, because 0 is the ground. Don't forget 0. What is the highest that Jack gets above the water? So 0 is the water. So we are looking for a maximum point here. We are looking for the maximum point. We want to know the highest point. So we're talking about the distance. So we're going to go ahead and find that maximum. So we're going to calculate. So second calc. We're looking for a maximum. We need the left bound. So we're going to go ahead just a little to the right. Put in our left bound. Now we need our right bound. So go to the right side of the maximum point. Don't get crazy. I'm going to go right about there. And now we're going to take a guess. So where do I think the maximum point is? I think my maximum point is right about there. And so if you notice, it went ahead and gave me my information. We're rounding to the nearest tenth. I don't care right now about my x because we're just looking about how high does he get above. And we're rounding to the nearest tenth. So we're at 24.1 meters. And that's our maximum point. Last but not least, we have after how many seconds does Jack hit the water? So he hits the water, which means that's 0. So we're looking for our 0. So we want a second calculate. We want a 0. So we're looking for 2. And now we need a left bound. So we want to go to the left side of our x-intercept. So I'm going to put my left bound right about here. I need to go right bound, so right side of my x-intercept. So I'm going to go right about here. And now I'm going to take my guess. I think my x-intercept is there. So if we notice, 0 is when he hits the water. So my time, because x is seconds, we're going to round to the nearest tenth, is 3.1 seconds. And that's because we looked at our x-intercept. Okay, so that is how you determine what is going on when we are looking at quadratic equations.